Welcome to Hello and welcome. We are live from the campus of Western North Carolina University in the campus television studio. Tonight we have a robotics scrimmage between IEEE chapters of WC Asheville and WCU. Tonight they are going to be doing a practice competition before next month heading down to Florida to compete in the Southeast Con Hardware competition. Before we get started, though, we have the chair of the IEEE North Carolina Council, Charles Lord, to discuss a little bit about all the great things that IEEE does. Charles?
Thanks. Glad to be here. What is the IEEE? So let's put up a slide here and talk about it here. For those who are unfamiliar with the IEEE, we are the world's largest professional association advancing technology for the benefit of humanity. It publishes technical journals, sponsors conferences, develops technology standards, and supports the professional interests of more than 400,000 members. IEEE creates an environment where members collaborate on world-changing technology, some of which you'll see demonstrated in the competition tonight, and also in computing as sustainable energy systems to aerospace, communications, robotics, and healthcare to engineer a better tomorrow. To give a better idea of how we fit into all of this, IEEE is divided into 10 regions worldwide. Our region, which is called Region 3, consists of the southeastern U.S. and Jamaica. Yeah, man. Within Region 3, there are over 40 local sections. Our section, West North Carolina, has about 400 members there, and also includes 2 great student branches, which you will see in competition tonight, and they're represented here today. Going back over 50 years within our region, we've hosted a conference each spring. This conference, called Southeast Con, moves between different locations around the region and includes a student conference that features many different competitions between the schools throughout the region. But the highlight of this has always been the hardware competition, a test of skill where the students have to design, build, and use an autonomous robot to carry out a series of defined tasks without any interaction from the team itself. In these pictures you see on the screen from the 2017 competition that was held in Charlotte, you can get a feel for the different designs the students may come up with, and the atmosphere as the teams watch their robot carry out its tasks. Again, unlike many other robot competitions that you may have seen in the past, these robots have to operate completely autonomously, on their own with no interaction from the team. Which brings us to today. A few years back, the IEEE Western North Carolina section and the 2 student branches here decided to start holding a friendly competition before Southeast Con to test out their designs under a competition setting and to foster networking between the 2 schools. And of course, to get bragging rights for the Western North Carolina Robot Challenge. Last year, UNCA won, and both schools went on to excel at Southeast Con in Mobile. UNCA placing 2nd overall, and Western Carolina winning in the open competition. Now, who's going to win tonight, and how will they do at this year's Southeast Con in Orlando? Let's see the robots in action. Back to you.
Well, thank you so much, Charles. I'm excited to see what goes on tonight with the robots as well, and it sounds like IEEE is doing a lot of great work and a lot of great things coming up in the future. So with that being said, it's time to get into tonight's competition. Each team has designed a robot to simulate a disaster relief and cleanup in a manufactured course. The background of the competition is that we are pretending that a hurricane has hit Orlando, Florida, and it is our team's jobs to clean up the part of the city. The course is 4 feet by 8 feet, and the robots that have been created and designed to clean up poker chips, which are representing food for alligators and manatees, and the ducks symbolize ducks that need to be returned to their duck pond. There is a unique way that this competition is being scored. Here's a little bit more information on how tonight's competition will be scored.
Okay, let's go to the scoring for today's competition. What you see here is the aftermath of a hurricane. You got debris and ducks scattered all around. Normally the ducks are in this blue circle, the duck pond. These cylinders are pieces of statue that's in the duck pond. But you also have predators. This green square represents alligators. This red square represents manatees. Both are predators, would love to come and eat the ducks. So there are food items here. This is alligator food. These green chips are alligator food. These red chips our manatee food. The robot starts in the square at the beginning of the 3-minute run. If the robot can take alligator food and put it in the alligator area, or manatee food and put it in the manatee area, they get 7 points each for each chip placed. If you do the opposite and do like alligator food in manatee area or vice versa, you get 3 points for each chip placed. If the robot places for each duck that is placed in the duck pond, you get 5 points. There are 2 recycling areas, both here on the right and here on the left. This black and white striped area. Any object placed in this recycling area gets 2 points, either a duck or a food chip or the pedestal pieces. There's an auto start feature. There's an LED that will light when the referee goes 5, 4, 3, 2, 1, go. The LED will turn on. If the robot is activated on the LED just alone with no human interaction, then you get the full 10 points. There's a toggle switch down here. Right now it's in the on position. In the test it'll be actually slanted to the, at the start it'll be slanted to the left in the off position. So if the robot can come down here and toggle that switch, the team would get the full 10 points. Now it will not start any actual fireworks. So that's the scoring. Good luck, teams.
Hey, welcome back. While that video was playing, we had a coin toss here in the studio to see which team would be presenting first. So without further ado, I would like to welcome Captain Chase Condor and Coach Eli Buckner. Introduce yourself a little bit. I'm sorry, guys. Sorry, I got a little flustered there.
So my name is Dr. Eli Buckner. I am a teaching professor at UNC Asheville for our joint engineering program with NC State. I was a part of this competition whenever I was a student, so now I'm the faculty advisor, so it's great to do this again.
Yeah, and I'm a student in most of the classes, Chase Condor, and I'm, I guess, junior year at this point. It's kind of hard to say with our classes. Junior or senior.
Hey, all we need to know is that you're the team captain. So with that in mind, tell us a little bit about your robot design.
Yeah, so we basically went for a sort of like oil rig sort of structure design, so that the idea is that we can have this entire intersection. As I should point out, a vast majority of our parts are missing right now. So this is a prototype electrical system and prototype for sensing the light coming on, and for this dropper as well. But the plan is to have we're going to use a Raspberry Pi and a camera and tensor to build a neural network and we've been working on this and I've got that decently working, to be able to detect the ducks and the pillars as well as their orientation, so that we can then flip them into the correct orientation to be deposited in the towers in the ponds.
Okay, so I'm sorry to cut you off, but you had mentioned you were missing a couple pieces. Do you think some of these missing parts and tidbits, do you think that'll hinder your performance today?
So with the rules today, they're sort of dumbed down from the main competition.
Okay.
So all of that is more for the main competition.
Okay, that's fair. All right. And what was the most challenging part of this build?
I would say most recently, the board that we were actually using to drive all this on failed on me. So over the past 4 days, I soldered up and redid the entire electrical board.
Well, I think it's about time that we check out and see what this thing can do on the course, right?
All right, yeah.
All right, let's make it happen. And I think up here, while we have the event going on, I'll be joined with Dr. Buckner and Chase Condor as well for some commentary. Oh, well then, let's... So the one thing that I definitely read up on when we started out is there's was that 10 points for the automatic start?
I believe so.
Okay,
yeah, I'm
okay.
Little rusty on the points for exact.
I'm brand new,
Tools.
baby. Oh, 10 points? Okay. So then, so the pathing we have right now, I mean, is that...
Yeah, so basically what it's going to do is we had it just go directly left, and we tried to drop the red chips into the red box, but it looks like our position was slightly off, and I missed those. And it seems our... Okay, we got one. And the servos for our green need the position to be recalibrated.
Okay.
So it looks like that's why those didn't come out. But so right now it's running through the loop where it's going to sweep all the ducks to one side, and then the plan is to come behind those ducks and sweep them all into that top right corner.
So come the competition, are you going to be able to pick out, say, like, go specifically for the ducks? Or
Yeah,
like,
so-
okay.
So the plan is we'll have a sort of collection system.
Mhm.
Ooh, a little skippage. Has a collection system and a drum for storage. So it's gonna go down and basically detect a duck, detect its orientation so that it can correct that orientation,
Okay.
and put it in our storage cylinder in that orientation that we know. So
So-
then we can stack it on top of the
So
pedestals.
that open spot there in the middle, is that where the stacking spot's going to go?
Yes, sir.
Oh, okay, okay.
So here it should be going for the final push.
Try to rack up as many 2 points as you can.
Yeah. Could have gone a little farther, but... So here is us trying to get the switch, but I guess not. So
Alright.
that's it.
Yeah, that's it. All right, not too bad. I guess we should tally up some scores, right?
Yeah, if someone could flip the switch on that.
Oh, the
Yeah,
Flip
you got it?
all right. I guess yeah, sweet. All right, okay, so sorry for the awkward pause, but now that we've seen that your robot in action, were you happy with the results, or what do you think you need to work on?
I mean, I think we're at this point pretty happy with where we are. In my mind, as long as it did what it did there, I'm happy. What do you think?
I mean, I guess it's better than we were last year at this point.
Yeah.
So yeah, we could be happy with that. I guess wanted to have a lot more done by now. So
Well, is there anything you want to, any
Little bit
immediate
of
changes that you want to make, or?
well, so the major change that is going to be made is changing from open loop control to a closed loop control.
Okay.
So right now there's no feedback on its position as it goes throughout that maze. So it's just counting the amount of increments that each wheel has made.
Yeah.
So you can see that caused a little bit of error by the end because the compounding error from multiple moves. So we want to get rid of that compounding error.
Absolutely. All right. Well, I think that just about does it, and we are going to go ahead and switch over to the Western Carolina team.
Okay,
Thank you guys so much. Let me just set this down right here. Thank you very much. And I'm so sorry. Before we go, if we can just go ahead and just show the team that just performed UNCA, I'm terribly sorry. And now joining me up next, we have the team captain for WCU, Benjamin Carpenter. Right over here. And then we also have their coach, Dr. Adam Harris. Well, thank you guys so much for joining me. And,
Thank you for having us.
First and foremost, tell us a little bit about your design.
So we went with kind of a square body design with maker beams, and then we trying to just put all of our circuitry on top. It's a little messy right now, but closer to competition, we'll clean it up more. And then we just have two main motors with wheels attached on the sides, and then we have just two caster wheels on the front and the back, and then we have a plow to push everything in the front.
Okay, so that's what I was just about to ask. We see the other team with their oil rig style setup, and then you have the plow, are you going to do the same technique and just kind of shove everything into one of the corners?
Looks like that's the plan.
Oh, okay, okay.
So this wasn't planned. We didn't know that was what they were going to do as well.
Oh,
So.
look at that. And then, what was the hardest part about designing this this robot?
Well, the hardest part was definitely getting our two Arduinos to be able to talk to each other and just making sure everything is where it needs to be at the right time. Like I said, we're still in the prototyping phase, so a few of the wires coming out or just becoming loose could
Right.
cause a big problem. So,
All right. So then, what do you hope to see from this robot today?
well, we're hoping to see it work, and then after
Score
that,
some points. Yeah.
exactly, score some points.
That was a little obvious. My
But
bad.
yeah. And then after that, just here to have fun and see it work.
All right. Well, then, if we can, just go ahead and flash the Western Carolina team. Hi. And I guess without further ado, we can go ahead and start this next competition. All right. Are we ready to get this? Are we ready to start it? All right. Let's do it. Automatic start.
Yep.
So you see UNCA, they went straight for the right corner, but you went for the back corner. Is that... Oh, maybe I should watch and not talk. Ooh.
Well, there goes the plow.
Yeah. So what's going on right now? They
So,
just lock into the corner?
well, I guess it's not working how it was supposed to, and now appears to just it's trying, but it's not doing anything substantial.
That was pretty good. I mean, yeah.
I mean,
I think that's a point, isn't it?
oh yeah, that's 2 points right there.
Yeah.
So,
Okay. What's it gonna do next?
that's
Could
a
be
good
anything.
question. I don't think even we know what that's going to do.
It's trying to pick the plow back up.
Yeah. All right. Well,
There's still time.
I think it's stuck. So,
Oh no.
let's call the match.
I think that'll do it if you guys want to flip the switch. Oh, never mind. Sorry.
All right. Oh, I think we got stuck on a duck there.
She's just working.
Yeah, she's trying all right.
So what's up with these little quick cuts and quick jumps? What do you think that is?
So originally that was planned to just, or programmed into the robot to be able to move it backwards, and we changed it last minute to make sure we could get the poker chips into the different habitats that we needed them in, but the plow fell off early, so it just wasn't doing what it needed to now.
Oh, oh. Every time we say it's just about done, it keeps moving. Gives us another reason to let it keep going.
Oh, man. That's just the starting square. That doesn't give us points.
Oh, oh.
Oh.
What a tease.
No. It keeps getting our hopes up.
There we go. Here we go. Maybe? Oh. These dang ducks.
No.
Yeah.
This is what the plow was for, so the wheels want to get caught. All right, well, I just heard it's been 3 minutes, so.
I think that just about does if you'd like to flip that switch. If you guys would like to come back up. So it seems like that maybe didn't go quite the way you wanted it to go.
No, it did not.
So what can you improve upon for April?
Well, we intend to improve upon our plow design for our competition.
Yeah.
And we're definitely going to be cleaning up our wires and having better cable management.
Okay, and then, it's something I didn't ask UNCA, but I'm curious, how do you start the design process for something like this little guy with the plow on it?
Well, the plow was something we came up this semester. We had a newer student to the club come in, and he wanted to tackle that project. So
Okay.
we let him do that, and that was the design he came up with. And so it worked on paper, and it worked a little bit before this, but obviously it's not as consistent as we'd like.
Yeah. Well, hopefully you can get that tweaked and figured out and ready for Orlando.
Sir.
And then for you, I'm so sorry, Dr. Harris, what did you think of the performance?
Well, to be honest, anytime you're doing a live demo of something, something's going to go wrong.
Oh, yeah.
So it's always a flip of a coin if it's going to do the thing that you programmed it to successfully, or something's going to fall off.
Yeah.
And then, So honestly, for a single run, everything relying on that, it was just kind of a bit of a fluke, I feel like.
Yeah.
But we definitely could improve on some of the design so, the front doesn't fall off. And of course, we also plan to have computer vision on there. We've got a team working on that now.
Oh, wow.
It just wasn't ready for prime time, you know.
Yeah.
So, but by a month from now at the actual competition, we should have, duck recognition at the very least working pretty well. And we've got also a arm that half the team was working on as well, an arm to pick up the cylinders and position them correctly in the right orientation. So those things obviously are going to have to be added to the current design as well. And so we definitely just need to go back and tighten up a lot of the loose ends, literally and figuratively, and then add these new systems. And I think we got a month to do it, and I think we could do a good job
Plenty
of it.
of time. All right. Well, thank you guys so much. It was pretty fun, and I think we're gonna take a little second to count up the scores and then come back and figure something out.
All right, thanks.
Yeah, no problem. No, actually, I'm terribly sorry. I skipped through UNCA very quickly, and Dr. Buckner here had a couple things to say about UNCA, and I'm sorry. So.
Oh, that's all right. So as Luke said, my name is Dr. Eli Buckner. I am an assistant teaching professor in electrical engineering for the joint NC State UNC Asheville engineering program, and now faculty advisor for our IEEE student chapter. Our program is a joint collaboration between the two UNC system schools, UNC Asheville and NC State. Our students, whenever they come to us, choose one of two routes to take while going through our program. The first route is mechatronics engineering, which is a combination of mechanical engineering, electrical engineering, and computer science, all in one degree. Students spend all 4 years of study at UNC Asheville, but earn a joint degree from NC State and UNC Asheville, a Bachelor's of Science in Engineering with a concentration in mechatronics. This program is one of only 4 ABET-accredited mechatronics engineering programs in the United States and is not available on the Raleigh campus of NC State. The second route that our students take is the 2+2 engineering program for all engineering disciplines except for mechatronics. Students complete 1 or 2 years at the UNC Asheville campus, taking core engineering classes and then transferring over into NC State to concentrate in any of the engineering majors that NC State has to offer. This route results in a degree solely from NC State. So that's a little bit about our program. And if you would like to know more, please visit our website at engineering.unca.edu.
All right. Well, thank you so much, Dr. Buckner.
Yeah, absolutely.
And up next, if we could just chat with Dr. Bob Adams. And there you are, sir.
Yes, I'm a professor in the electrical engineering program, and I'm stepping down as coach for the last many years. The College of Engineering and Technology offers 4 ABET-accredited BS degrees and 1 MS degree. The BSE program offers concentrations in mechanical and electrical power engineering. The ME concentration covers a broad range of mechanical topics such as statics, dynamics, fluids, heat transfer, and machine design. The electrical power concentration focuses on topics of interest to the electric power industry, such as the design and analysis of power electronic circuits and electric machines and drives, as well as a solid foundation of electrical and mechanical fundamentals. The EE program covers a broad range of electrical topics such as networks, electronics, control systems, signal processing, fields and waves, and communication theory. The ET program has a strong emphasis on the integrating theory of applications for mechanical systems, computer-based modeling, manufacturing and production processes, rapid prototyping, automation, quality assurance, and the development of automation robotic system. The ECET program focuses on the application of microcontrollers to the solution of industrial problems related to automation, instrumentation, and control systems in systems involving robotics, data communications, networks, and automated testing. And finally, the Master's of Engineering degree and Master of Science in Engineering Technology focuses on the integration of technical knowledge and management skills necessary for the effective improvement and management of technology-intensive systems. So all engineering and technology programs at WCU emphasize hands-on application and theoretical technical concepts through project-based learning, PBL. The PBL curriculum focuses on the development of critical thinking and decision-making abilities to help prepare students for the challenges that they will face in a wide variety of engineering and technology careers. There are 5 PBL courses required through each 4-year program. Each PBL course requires students to work in cross-disciplinary teams to solve design problems. By working in cross-disciplinary teams, students are able to bring their individual talents and skills together to make the sum greater than the parts and to gain experience in teamwork that will be invaluable in their future careers. The teams informally engage in friendly competition that adds to the thrill of working together on a project. The last 2 courses are in the senior year, constitute the engineering capstone. Students in the engineering capstone work on real-world assignments with both companies and with government agencies across North Carolina and beyond through our nationally recognized Rapid Center. The engineering and technology student clubs include IEEE, SAE Mini Baja, the Society of Women Engineers, the National Society of Black Engineers, and the Society of Hispanic and Professional Engineers, the National Society of so there's a couple others I can't recall outhand. The IEEE Student Club emphasizes professional development, teamwork, and recruitment of new members. The club is student-run. Officers plan each meeting and help members starting out to find their niche within the organization. Each year, the IEEE Club competes in the SoutheastCon hardware competition. Preparation requires hundreds of hours of planning and executions. Students do all of the work with close to 60 university teams throughout the southeastern U.S. competing at SoutheastCon. The hardware competition draws a huge audience with lots of exciting developments along the way.
Well, thank you so much, Bob. But if you would just hang out here for just a second, I'm going to bring Benjamin up here, and we're going to present you a little. He's up here with a special announcement. Excuse me.
Right, very good.
Dr. Adams, we know you're retiring this year after about 10, maybe 15 years of being our faculty mentor.
Yeah.
And so we just wanted to give you this as a token of our gratitude.
Thank you so much.
If you want to open it.
Very nice. Thank you so much. I really appreciate that.
Yes, sir. And
Well, what is it?
It says in recognition, Dr. Robert Adams, thank you for your guidance and leadership, IEEE student group. Very nice.
Beautiful.
Thank you.
Very welcome.
let's. Oh, wait, the camera can read it. Right.
Well, thank you, Benjamin. Thank you, Bob.
Yeah.
Thank you.
Got that a little backwards. I'm sorry. So sorry about that. But now it's time to announce the final scores. And Charles, if you would come back up and join me again. Absolutely.
Do we need a drum roll?
I think it's only fitting. It is UNC Asheville.
University of North Carolina, Asheville. If you would come up here and join me.
Hey, join the party.
Nope.
No, you come through. Come through.
You're important. I'm not important to be in here.
I've had enough camera time. I've been stuttering my way through this whole thing.
So again, somebody can hold on to that. So for the second year in a row, UNC Asheville has won our robotics challenge, and so we wish the best of luck to both teams as they go to Orlando and compete for the championship of the region. So thank you very much.
Thank you so much.
Thank you.
All right.
Congrats. All right, I think that just about does it for us here at WCU.
Okay, so big question is, who's going to walk away with the trophy in Orlando?
Oh, Orlando. Gee, I totally forgot about that part. Well,
Yeah.
based on the designs, you know, I really like the plow. Yeah, I'm also, I don't want to say I'm biased because I go to WCU, but I just like the plow idea because you can just shove everything in a corner and rack up as many points as you possibly can.
Well, one thing is that we kind of surprised, although not that much last year, because Western did go into the open competition last year, and they won it.
Okay.
They won it all in the open competition, and UNCA came in second in the entire Southeast in the regular competition with the schools. UNC Charlotte actually won first, but I think they've got a good chance of going after them this year.
Yeah, right, okay.
And stuff. So, yeah, some of us from the state are biased, but we like to see schools from the state win these championships.
Well, it's you know, for me at least, it's Western pride. You know, I got to cheer for my team, the boys and girls in purple. Do you have anything else?
No, I think that we ought to. We have pizzas on order that are not here yet, so we have food for everyone who's here that wants to have some pizza and soda. I know students don't like that anymore, right? They want something else to eat. I know that I ate way too much pizza when I was a student 100 years ago at NC State, but we've got food coming. For those of you who are joining us on YouTube, we hope that you will stay tuned. That unfortunately our channel for the Western North Carolina section was not able to log in tonight. We're going to get YouTube to fix that out. We're very thankful to Western Carolina TV for doing their backup broadcast on this, and the recording of this will be on both channels after this. But stay tuned. We will be covering the trip of both these teams as they head for Orlando and go to the competition.
Wonderful.